So we review from yesterday. We have this quadratic in vertex form. We're going to answer the following. So the turning point would be -1, -4. Again, this is the x value of our turning point, but opposite. And then this is the y value of our turning point, but the sign stays the same. The graph is positive. There's no negative out in front, so that means it's opening upwards. So the turning point is a min. The axis of symmetry is just x equals whatever the x value of your vertex is, which is -1. And the y-intercept, you can either plug it in for 0, or we can wait and see what this is in standard form and then get our y-intercept from there. So let's go ahead and write this in standard form. So we have 6. To write it in standard form, we're going to break this up. We have x plus 1 squared, so that's the same as x plus 1 times x plus 1, and then -4. So what I like to do to get rid of this 6, I'm going to distribute the 6 just to the first parenthesis. So we get 6x plus 6 times x plus 1 minus 4. Then we're going to FOIL. So when I FOIL here, I get 6x squared plus 6x plus 6x plus 6. And then don't forget to bring down that -4. Then we're going to combine our like terms. So we get 6x squared plus 12x plus 2. And that is the same exact quadratic, just in standard form. And from standard form, we can get our y-intercept. Our y-intercept is just c, so our y-intercept is 0, 2. Or you could have just plugged 0 in for x. So as you can see, writing a quadratic function in standard form from its vertex form is relatively simple. You just end up foiling and combining like terms. Well, we can go the other way. We can go from standard form to vertex form. We can rewrite the quadratic equation in vertex form if we use a method which might sound familiar, complete the square. This is what we did last unit when we were solving quadratics. We can use the same method to turn a quadratic into vertex form. So it's very similar steps, but there is a slight twist. What you're going to do is move c over to the other side. So you're going to get all the terms with the x on one side and the constant or the number on the other. So all the x's go on one side, everything else goes on the other side. In order to use completing the square, remember a, the number in front of x squared, has to be 1, the leading coefficient. If it isn't, when we were solving, we divided everything by that number. But we can't do that this time around. So what we're going to do is factor out that leading coefficient. And then we complete the square as normal. We add b squared divided by 2, or b divided by 2 squared to both sides, factor, and solve for y. So this is actually much simpler in my mind than what we did last unit. So let's take a look at an example. So what we're going to do is take this number in the back and move it over the other side. So we're going to take that -6 and we're going to add it. We're going to move it over with the y. So we get y plus 6. And I'm going to put plus a box. And I'm just going to put plus a box squared. Equals x squared plus 6x plus a box squared. To fill in those box squares, we're just going to take our middle term, in this case 6, and divide it by 2. So off to the side somewhere, we have 6 divided by 2, which is 3. That's what we're filling in our boxes with. We have 3 squared. B divided by 2 squared. Then, clean it up. We are going to plug that in. So we get y plus 6 plus 3 squared is 15. Good, 3 squared is 9. 6 plus 9 is 15. Equals. And we're going to factor. If you, I'll do the long way here. When we factor, remember we make 2 parentheses. We have x squared in the front 3x in the back, so each one becomes x plus 3 and x plus 3. So we can condense that down and we get y plus 15 equals x plus 3 squared. Remember from last unit, we can go from this step to this purple step. We can kind of skip that green step in between. Okay. And then get y by itself. To get y by itself, all you have to do is take the 15 and move it back over. And you just kind of stick it at the end. So we get y is equal to x plus 3 squared minus 15. And there we go. There is the quadratic in vertex form.